Question 30A. A set of data has a lower quartile of 10 and an upper quartile of 16. What is the maximum possible range for this data set if there are no outliers? Let's have a look at the formula sheet to see if there's anything that could help us. Data analysis, outliers, upper quartile. Okay, this is what we need. I'm going to write this down. To begin with, we need to know what the interquartile range is, or IQR. And that is just 16 minus 10, because that's the range between the two quartiles, therefore interquartile range. And that is 6. Now we have a figure for that. And all we have to do is just substitute in the numbers that we have. Therefore, the low one, the lower quartile is 10 minus 1.5 times the interquartile range. And that's 1. Similarly, we have 16, which is the upper quartile, minus 1.5 times the interquartile range. Oh, sorry, plus. And we've got 25. If there are no outliers, the maximum possible range, max range, is gonna equal 25 minus 1, which is 24. Let's see what they say. Yeah, perfect. Question B. The cost of a jewelry box varies directly with the cube of its height. The jewelry box of height 10 centimeters costs $50. Calculate the cost of a jewelry box with a height of 12 centimeters for 2 marks. The equation of this would be the cost of something is directly varies directly with the cube of its height multiplied by any constant that we don't know of. We know that when the height is 10 centimeters, cost is $50. We sub that in and we can find the constant. Now that we have the constant, we can do the rest of the question, which is what is the cost of the box when the height is 12 centimeters? And that is $86.40, which is more than the 10 centimeter box, which is good, because it should be more expensive. Let's see if it's right. Yes, excellent. Question 30C. The diagram shows the location of 3 schools. School A is 5 kilometers due north of School B, and School C is 13 kilometers from School B, and angle ABC is 135 degrees. For 2 marks, calculate the shortest distance from School A to C to the nearest kilometer. And everything's already in kilometers, so that's good. Basically, this is trigonometry. You have, oops, that's terrible, triangle, but whatever. You've got 5 kilometers, 13 kilometers, and you are trying to find this side. You would use the cosine rule for this, which is a squared equals b squared plus c squared. minus 2bc cos A. Then you just sub everything in. I'm gonna make this side has to be the A, because that's the only angle that we have. We only have angle A, therefore this side has to be A. B, doesn't matter which side you put these in, doesn't really matter which one is B, which one is C, just pick one, times cos 135 degrees. And then you just put everything in the calculator. Okay, 285.92388 ... Keep that in your calculator, do not round it, because now we have to square root both sides, which gives 16.90928 ... Let's see what the question says. To the nearest kilometer, and that is 17 kilometer, and that is longer than 13, which is also good. Let's see if it's right. 17 kilometers, excellent. Question 2. Determine the bearing of school C from school A to the nearest degree for 3 marks. So let me draw this for you. The bearing that they want is this one. They want to know how many degrees that is, and we can't find that out on its own, so I need to draw the rest of the triangle out, and I need to find this angle here first. I've just named it alpha. If I can find alpha, I can find the rest of the bearing. To find alpha, I can use the sine rule, which would be 13, which will be sine alpha on 13, oops, it's a funny 3, is equal to sine 135 degrees on 17. Then times 13 to both sides. Find out what that is. 0.5407 ... And then I'm going to find what alpha is by taking the inverse of sine. This is an angle, put as an angle, 32 degrees 43 minutes 59.73 seconds. To the nearest degree, but not yet. What I now need to do is add 180 degrees to it, and I'll find theta. Theta will equal to 32 degrees 43 minutes 59.73 seconds plus 180 degrees, which is going to be 212 degrees 43 minutes 59.73 seconds, which is rounded to 213 degrees. Therefore, the bearing from school C to A is 213 degrees. Yay! Excellent. Question 30D. In an investigation, students use different numbers of identical small solar panels to power model cars. The cars were then tested and their speed measured in kilometers per hour. The results are summarized in the table. Number of solar panels, speed. The equation of the least squares line of best fit relating the speed and the number of solar panels has been calculated to be this. 1. What would the speed of the car powered by 5 solar panels based on this equation? Number of solar panels is x, speed is y. We just have to put 5 in where the solar panels should be. Y is equal to 2.125 times 5 plus 2.0375. And we should get the speed from that. The speed is 12.6625 kilometers per hour. Do I need to round it? No, let's see. Yep. Next, calculate the correlation coefficient R between the number of solar panels and the speed of the car. Let's see if there's anything that could help us at the back. R, correlation coefficient. Okay. I'm gonna write this down. Now that we have the formula, it's just a matter of subbing everything in. So we need to substitute the gradient, which is 2.125. We need to substitute the standard deviation of the y, which is 2, and standard deviation of the x, which is 0.8. Okay, 2.125 equals r times 2 over 0.8, which is equal to 2.5 r. Then r is gonna equal 0.85, and that is the correlation coefficient. Let's see. 0.85. Excellent. 30E. A solid is made up of a sphere sitting partially inside a cone. The sphere center O has a radius of 4 centimeters and sits inside of the cone 2 centimeters. The solid has a total height of 15 centimeters. The solid and its cross-section are shown. What is the volume of the cone? Correct to the nearest cubic centimeter. So the question really is just asking us for the volume of the cone. Now, whether it wants the volume of the entire cone or just the volume that's the free space that's underneath this sphere, I'm not sure of, but it's asking for the volume of the cone. And thinking about it, if it is asking for the volume that's underneath the sphere inside the cone, it will be incredibly difficult to find. So difficult that I don't think it's part of the general maths syllabus that's covered. So I'm just going to assume that it is just the volume of the cone. Just pretending that the sphere isn't even there at all, and just find the volume of the cone. So let's get into it. So for the volume of the cone, what we need, for the volume of the cone, it would be pi r squared h on 3. We can find the height first. The height is not 15 centimeters. We need the height from the end of the cone to the other end. That means we have to get rid of this height, which will be 6 centimeters. That's 4 from the edge to the middle, and that's another 2 in here, because since that's 2, this has to be another 2 to make the 4 centimeter radius. So we need to take away 6 centimeters. Now that we have the height, we need the radius of the cone, and it's not 4 centimeters because it's not going from the middle of the sphere to the edge. It's this one here, and I can use Pythagoras theorem to find that. R squared plus 2 squared equals 4 squared. R squared plus 4 equals 16. R squared equals 12. R is root 12 centimeters. Now that we have the radius of the cone, we can now find the volume. I'm just going to write it over here. Okay, now it's time to just sub everything in. The volume of the cone is pi times root 12 squared times 9 over 3. 113.097 ... The question wants it to the nearest cubic centimeter. That is 113 cubic centimeter. Therefore, the volume of the cone is 113 cubic centimeters. Excellent! So, did that help you with your studies? Do you want me to make another video completing another HSC paper? If so, which one? Please let me know by clicking that like button and commenting below on the paper you want me to do. Until then, have fun practicing. Bye!